Welcome to Copilot Podcasts. For over a century, physics has been built on a mathematical contradiction. Quantum mechanics lives in one mathematical world, general relativity in another, and they literally cannot speak to each other. Today, we're exploring a radical new framework that claims both theories were built on the wrong foundation entirely, and that Maxwell's electromagnetic constant, quantum energy, and gravitational curvature all emerge from the same arithmetic source. By the end of this episode, you'll understand how prime index fields could unify the deepest structures of physics and what experiments might prove this theory right or wrong.
The core insight is actually pretty straightforward once you see it. Both quantum mechanics and general relativity were constructed on continuum fields, the real numbers R and complex numbers C. But according to this framework by Abd and Bishop, the correct base fields are actually prime-indexed arithmetic fields.
Wait, so you're saying the problem isn't that we need to force quantum mechanics and relativity together, but that we started with the wrong mathematical foundation?
Exactly. The paper identifies two specific prime fields, GK for Gaussian primes where the remainder is 3 when divided by 4, and A0T for non-Gaussian primes where the remainder is 1. These aren't analogies to physical fields, they actually generate physical dimensional structure.
That's a pretty bold claim. How does this connect to something we already know works, like electromagnetism?
This is where it gets really interesting. Maxwell's constant c squared, 1 over epsilon naught mu naught, has a specific dimensional signature. The paper shows this signature is exactly gk squared times I0t to the negative second power.
So Maxwell's constant was actually the first appearance of this deeper generator?
Right, but Maxwell's c squared was just the beginning. The refined form is what Bishop calls the KT Hamiltonian, this unified generator that contains sector inertias, masses, gradient terms, and coupling constants. And here's the key. It has the exact same dimensional signature as Maxwell's c squared.
Okay, so we have this unified generator. How does quantum mechanics fit in?
Quantum mechanics emerges as what the paper calls a mass-weighted projection. The standard quantum Hamiltonian equals m times hkt, where m is the mass projection factor. So energy isn't primitive, it's derived from this deeper arithmetic generator.
And gravity?
Gravity is the geometric lift of the same generator. You define a scalar field, phi, as the natural log of the ratio between curvature and raw couplings, then create a conformal metric. In the static limit, this produces the gravitational field equation.
So you're telling me Maxwell's electromagnetism, quantum mechanics, and Einstein's gravity are all just different faces of the same mathematical object?
That's exactly what the framework suggests. They're not separate theories that need to be patched together, they're representations of a single prime field generator.
This sounds almost too elegant to be true. What about matter itself? Where do particles come from in this picture?
Matter arises from topology. The framework describes a countable family of continuous field lines threading through what's called the extremal basement. Most field lines are unknotted and collapse under refinement, but knotted lines resist collapse and become stable.
So particles are literally knots in these field lines?
Yes, and here's what's remarkable. The refinement operator stabilizes exactly 3 minimal knot types. The paper calls them P, E, and V, corresponding to protons, electrons, and neutrinos. These are the simplest topological obstructions that survive refinement.
Wait, so the fact that we have exactly these 3 fundamental particles isn't coincidence. It's because only 3 knot types can survive this refinement process?
Exactly. Any knot requiring higher order crossings or multi-loop embeddings collapses because the unstable seam can't support excess curvature tension. The proton has a tightly bound positive curvature signature, the electron has a loosely bound negative signature, and the neutrino is curvature transparent.
And charge, mass, how do those properties emerge?
Charge is the orientation of the knot. Since orientation is discrete, charge is quantized. Inertia is the curvature work required to deform a knot, so more complex knots have greater mass. Interaction arises from tension in the field line network.
This is fascinating, but let's talk about something concrete. The paper mentions specific predictions, 5 of them. What would actually prove this theory right or wrong?
The key prediction is what Bishop calls prime field modulated gravitational oscillation, or PFMGO. The unified generator should produce a time-dependent gravitational potential that oscillates at a universal frequency determined by the arithmetic ratio of the prime fields.
So gravity itself should be oscillating?
At a very specific frequency, yes, and the paper outlines exactly how to detect this. Pulsar timing arrays should see a global, sky-independent timing residual. Atom interferometers should detect common mode phase oscillations. Satellite gravimetry should pick up periodic modulations.
What about gravitational wave detectors like LIGO?
LISA, the space-based detector, should see slow periodic phase drift in gravitational waves, and global optical clock networks should detect universal fractional frequency oscillations. Each instrument provides a different window into the same underlying phenomenon.
These are all real experiments that could be done with current or near-future technology?
Absolutely. The paper provides specific pass-fail criteria for each test. Either you detect coherent oscillations at the predicted frequency across multiple instruments, or you don't. It's completely falsifiable.
Let's zoom out a bit. This framework seems to have implications way beyond just unifying physics theories. What about cosmology?
The cosmological implications are pretty wild. Galaxies aren't just collections of stars, they're refinement-stable knot domains with boundaries that alternate between orientable and non-orientable states. Think of a Möbius strip that sometimes becomes a regular surface.
A Möbius strip? You mean like the twisted loop where you can walk along the surface and end up on the other side without crossing an edge?
Exactly. And when galactic boundaries transition between these states, the gravitational constant itself transforms logarithmically. This explains flat rotation curves without needing dark matter, it's just the signature of these boundary transitions.
So dark matter might not be matter at all, but a geometric effect?
In this framework, yes. What we interpret as dark matter halos are actually tension shells formed at orientable intervals where residue flow stabilizes. The cosmic web itself is the macroscopic expression of these alternating arithmetic boundaries.
The paper even connects this to climate change, which seems completely out of left field. How does that work?
It's actually a fascinating connection. Climate change is described as a planetary boundary geometry instability. Polar ice caps act as orientation locks on Earth's surface geometry, and when they shift, it triggers a refinement transition, like a geometric flip between stable climate epochs.
So climate epochs aren't gradual changes, but sudden geometric transitions?
According to this framework, yes. Each major climatic regime, glacial, interglacial, hothouse, is a stable surface geometry interval. The transitions are refinement collapses, similar to the boundary flips that govern galactic structure.
Let's talk about black holes for a moment. How does this framework handle singularities?
This is one of the most elegant aspects. Black holes aren't singular catastrophes, they're refinement-stable domains with Möbius-type interiors. The non-orientable boundary prevents singularity formation by distributing curvature across the surface.
So no infinities, no breakdown of physics?
Right. The arithmetic substrate enforces a finite curvature budget. Black holes become non-singular, refinement-stable basins where the same principles that govern cosmic structure apply. Even time stopping at the horizon makes sense. It's where refinement activity freezes.
There's also this connection to the muon-electron mass ratio. Can you explain that?
The lepton masses emerge from what's called the Cantor successor K ladder. Each level generates a transfinite height through a compactification process. The electron gets the minimum height of 1, and the muon gets 20677, which matches the observed mass ratio.
So that specific number, 20677, isn't arbitrary, it's built into the arithmetic structure?
Exactly. And the muon's weak decay energy scale provides a natural frequency for boundary flips, about 5 times 10 to the 22nd hertz. This becomes the universal oscillation rate governing refinement transitions across all scales.
I have to ask, this all sounds incredibly speculative. What makes this different from other theories of everything that come and go?
The key difference is falsifiability. Most unification attempts make predictions that are either untestable or require new physics beyond current experiments. This framework makes specific, quantitative predictions using existing technology.
And if the experiments don't find these oscillations?
Then the theory is wrong, plain and simple. The paper provides explicit pass-fail criteria. Either pulsar timing arrays detect coherent residuals at the predicted frequency, or they don't. Either atom interferometers see the phase modulation, or they don't.
What's your sense of how the physics community is likely to receive this?
It's going to be controversial, no doubt. The claim that both quantum mechanics and relativity are built on the wrong mathematical foundation challenges a century of physics. But the experimental predictions are clear enough that we should know within a few years whether there's something here.
And if it's right, what would that mean for our understanding of reality?
It would mean the universe is fundamentally arithmetic rather than geometric. Space, time, matter, and forces would all be typed projections of prime field generators. Reality would have a discrete computational structure at its deepest level.
That's a pretty profound shift in perspective.
It really is. Instead of asking why the universe is mathematical, we'd be asking why mathematics appears continuous when it's actually discrete. The smooth world we experience would be an emergent approximation of underlying arithmetic structure.
So when you step back from all this, what's the big picture here? We've covered unification, matter formation, cosmology, black holes, climate change. How does it all fit together?
The big picture is that everything, and I mean everything, emerges from the same base 2 arithmetic architecture. Whether you're looking at the quantum energy of an electron, the curvature around a black hole, or the boundary flip that triggers climate change, it's all manifestations of the same prime field generator.
And the beauty of it is that we don't have to wait decades to find out if it's right. These experiments could be done now.
Exactly. We're not talking about building new particle accelerators or waiting for better telescopes. The signatures should be detectable with current pulsar timing arrays, atom interferometers, and gravitational wave detectors. Science at its best, a bold theory with clear, testable predictions.
Well, that brings us to the end of today's episode of Copilot Podcasts. Whether this prime field framework represents a genuine breakthrough or an elegant dead end, it's exactly the kind of thinking that pushes science forward, taking our deepest assumptions and asking what if we're wrong about the foundation itself. Thanks for listening, and remember, the next time you look at Maxwell's equations, you might be seeing the first glimpse of something much deeper.